Parrish, Associate Publisher of Maximum Capacity Media, and your host for today's conference. Today is the third session of the 4-week event, which started on November 17th with a presentation from Tony Grote on fall protection. If you missed that presentation or last week's session by Dallas Dakin on aerial lift rescue techniques, log on to the web address at the bottom of the screen, www.saf-tconference.com, to watch a video from those sessions. I'd like to extend a special thank you to our sponsors for the safety conference, Skyjack, Hulot Group, and Aerial Work Platform Training and IPAF for their continued support of this event. Now in its fifth year, the safety conference maintains its objectives. Now in its fifth year, the safety conference maintains its objectives and commitment to the aerial lift industry. We aim to raise awareness of AWP safety, provide clarification on commonly asked questions and topics, unify industry efforts on safety, and ultimately help to save the lives of equipment operators and workers on North American job sites. Today's presenter is Brad Bueller, President of Skyjack, and he'll be presenting on the topic of aerial lift selection. Before we begin, I'd like to point out that you can ask questions via the chat box on the GoToWebinar panel. We'll have a follow-up question and answer session following Brad's presentation. We are also recording today's presentation, and the video will be available after the event on the MaxCap Media YouTube channel and on the Safety Conference website. With that said, I'd like to welcome Brad. Brad, please begin whenever you are ready.
Great, thank you, Katie. As soon as we get up here, I will hopefully have everybody looking at our presentation here now. And yes, as you mentioned, I just wanted to speak a little bit today about the selection of aerial lifts. And no, I don't want to do that, sorry. Okay. So a little bit about myself. As Katie mentioned, I'm the president of Skyjack. I'm a member of the ANSI and A2 main committee, chair of a couple of subcommittees at the ANSI level, also involved in CSA and ISO information. I'm an AWPT senior instructor involved in the IPAF Council and the chair of the IPAF Machinery Technical Committee Council as well, or Manufacturers Technical Committee Council. I wanted to talk a little bit about the selection of aerial lifts, and obviously part of that is to go through what type of equipment is commonly available on the marketplace today, and then how you make determinations between those particular pieces of equipment. So in general, certainly in the North American marketplace, we have manually propelled lifts, which looks something like this model here, which is a lift that's a vertical lift in this particular case, but the important part of this with respect to standards and selections is that it is not a free mobile unit within itself. It is manually propelled around the job site when in a stowed position. We have personnel lifts, which is similar to that last lift in being a vertical lift, but it is a mobile lift as well, and it is able to be self-propelled around the job site or to the place of work, and it is also available to be propelled in many cases while it's elevated as well. So we also have scissor lifts, which are commonly available. They are self-propelled generally as well, and if you look at these two photos here, we have an electric slab type scissor lift on the left-hand side, and we have rough terrain type scissor lifts, a little larger, and usually with a diesel engine or some sort of engine-driven unit. Also in the aerial lift industry, there's boom lifts as well, right? We have smaller slab lifts or larger rough terrain lifts. A couple of different types here that are shown. On the right-hand side is your traditional telescopic or straight stick boom lift, and on the left-hand side is an articulated style boom lift as well. And then finally, there are specialty lifts as well. Different types of specialty lifts. One that's shown here is commonly known as a spider type lift, although there are many different types of those. That's a trailer mounted type, but in general, you can get many different types of lifts that are available for various specialty applications as well. So how do you select the proper lift? Well, really what you do is a job site analysis, and I think everything breaks down back to that. And what is what is your job site and what are you trying to achieve on your job site. If we look at, there's some photos here of, on the left-hand side as an example. It's a little dark, I apologize, but it is an example of lifts being used appropriately on a job site. And as a matter of fact, they've kind of, in an airport there, they've taken advantage of the fact that there's little going on at the counters at that point. And they've actually used the line forming queue barriers there to actually create their own or cordon off their workspace. On the right-hand side, obviously, is an example of the wrong lift on the wrong job site, and obviously with not very good results. So when we talk about job site analysis, as I did, we really need to talk about the task analysis as well and what's going to occur on those particular job sites. And that leads you to asking a series of questions of yourself and of your requirements on the job site as to what you need to do on that site. So when you talk about, and I'm going to go through some of these questions briefly here and then in a little more depth as we go in, but really the first question is obviously how high, right? Obviously if in an aerial work platform, the assumption is that in general you need to get to a higher elevation, sometimes to a lower elevation, but generally a higher elevation. And so how high do I really need to get? Do I need to get 5 feet from the ground level, 10 feet, 100 feet, right? So certainly you have to ask that question with respect to the tasks you expect to perform on this particular job site. How close can you get to your task, right? So what is the required outreach to perform your task? You may or may not be able to get directly underneath or beside your task, or you may have to get around certain obstacles to get to your task at elevation. So who and what do you need to get to elevation, right? There are required capacities. There are capacities, obviously, on every aerial work platform with respect to how many personnel or how many people you can have on that lift and what material you can put at elevation as well. So you certainly need to know that while you're thinking about selecting an aerial lift. What surface will you be elevating on, right? You need to have suitable support conditions for that elevation, not only from a perspective of whether they're level or flat, but whether they're actually capable of bearing the weight of the or pressures of the particular lift that you're going to support. So you certainly have to know something about the ground conditions as well that you're looking to elevate on. And how are you going to get the lift to the task, right? In many cases, you may, in some cases, not have any obstacles between you and your task. It may be relatively straightforward. In other cases, you may have rough terrain or other obstacles in your way that you have to consider how you're going to get your lift there. So, and beyond that, there are some other factors that we'll go through quickly. So when we talk about the required elevation and how high we actually need to get, right? So obviously aerial lifts come in all different kinds of shapes and sizes and models as I went through there in the beginning. And so you need to make a definition between that. So if you answer the question about how high, obviously you're going to likely define a specific size range of lifts. And really lifts are generally broken out into different classifications, and they are classified by types of lift and by size. And so this first question here is really going to get you into a size range, and it is that is it something that is a 10-foot type lift? Is it a 20-foot type lift? Is it 30, 40, 60, 80, or 100? And so obviously, answering that first question will tell you how high obviously you need to get and define a size of lift that you are likely going to need. As you can see here, for different elevations, obviously this is a 40-foot machine here that we've got elevated. The requirement is obviously to get to near the top of this building. In this particular case, it may be a little not well defined from the photo, but a telescopic boom lift of a certain height, in this case a 45-foot lift, may be what you need to get up there. So the second question I put out was about the required outreach and how close I actually need to get to my objective on the job site. Or not how close I need to get, but how close can I actually physically get to it. And so that's going to define the best type of lift that you can choose to use on that particular job site to perform this particular task or this particular series of tasks. So again, as I said, if you can get directly beneath or beside your task, a scissor lift or a vertical lift, after you've determined the size, obviously, may be appropriate for your task. And so you're not limited to a certain, or there may not be any obstacles between you and your task or in that manner. And so that may be the appropriate type lift for you to choose. If you have to reach out to get to a task, a boom lift is likely more suited, right? Because you can get that outreach from various types of boom lifts. And in some cases where you don't necessarily have a straight shot, like that telescopic boom I showed in the last slide would allow you to get to, you may need to have an articulated boom lift of some type so that you can get up where your chassis is stationed, but also reach out from it at elevation to get over, you know, in mezzanine or other obstacles. And so some examples of this, obviously, if you've got an overhead crane like this, and you have a free space below it, that type of scissor lift is obviously could be an appropriate type of lift for that type of task. If you're looking more like this water tower, I believe this is, you need to get a little bit away from it, and you also need something that has the capability to traverse some rough terrain there as well in order to get to it. But we still have a suitable surface to elevate on where we are there. Some examples of not really choosing the proper lift for your objective. You see on the left-hand side there, you may, if you were working on that particular job and trying to get in towards where those windows are, you may actually need to have something that's got a smaller basket and or allows you to get a little bit higher than that first ledge so that you can get closer to your work area. Because obviously that's not appropriate to have one person outside of the lift and another person standing on the rails like that. And obviously on the right-hand side there, that's certainly some inappropriate behavior and obviously the wrong lift for that particular application. You really do need some other type of lift that will allow you to get up and over the contours of that aircraft, or you may need a specialty type of lift that allows you to get there as well. And so in both of those cases, in keeping with making sure everybody knows that that's inappropriate practice, we've put the do not do this symbol on top of it. So if you talk about the capacity, again, you have to know on your job site what tasks you're attempting to resolve or complete and decide who and what you need to get up into elevation. And so obviously, if you've got a job where you need to get 4 people at elevation and have them working in concert at elevation, you may have a different piece of equipment than a one-person job. Or even if you need 2 people to handle siding or pipes or whatever type of material you'd be working at when you get up there, obviously that's going to potentially dictate what type of aerial lift you're going to need on your job. So you have to talk about specific tools or materials that you may need at height as well. In some instances, you may just need to put a person at height in order to allow them to do labor that doesn't really require any tools or materials, or at least materials. And in other cases, you actually need to bring materials such as pipes or such as conduit or other pieces of material that you're going to install at elevation. And so obviously, you need to have a platform or an aerial lift that will allow you to bring those materials that you desire to bring up to elevation, or you're going to have to make alternate modes to bring the materials separate of the people to actually install the materials. And again, that will drive what particular aerial lift you may need on your job site. So again, if you look here, obviously we're trying to depict anyway that's a 2-person requirement to put that siding in place. And obviously you need a lift that will allow you to bring those 2 people up, but to also bring some of the associated equipment there up as well. So you have to have a lift that has a suitable personnel capacity, but also has a suitable material capacity as well. And they do vary, obviously, from lift to lift. So suitable support conditions, and we talk about what surface that you could or should or would be elevating on. And really that does become more and more appropriate, and I think we've seen more and more examples of this in the not too recent past, where the surface may not be sufficient for the type of lift that has been selected in that particular case. But ultimately, for most air elevating work platforms that you're going to have, you need to have a firm surface, obviously, and it needs to generally be a level surface as well. There are some lifts that you can get that will allow you to level yourself and or with the help of outriggers or even independent leveling of the lift itself. But in general, most of the time there certainly are parameters in which you must make a certain degree of being level before you're able to elevate the lift. Some units, as I said here, I guess I got a little bit ahead of myself, can actually be elevated on slopes. And again, you may be able to use those outriggers on certain units that have outriggers and are allowed to use outriggers to level the units to a certain degree. There are other units commercially available as well that will do self-leveling within the chassis of the machine itself and allow the elevating portion of the mechanism to go up in a level configuration, even though the chassis may be out of level. In all cases, you must be able to support the overall and concentrated loads of the lift, and that's what I referred to a little bit earlier. There have been some instances lately, or at least in the last few years, where we have seen lifts being used, usually generally larger telescopic boom lifts that are taken out in the street, and if they're put on the street itself or on the sidewalk, you really have to be cognizant of any underground utilities that may be running in that area, and understand that what the concentrated load of that particular unit and in what configuration the concentrated loads, where it could be the worst for a particular configuration. Ultimately, you have to understand what the conditions of the ground that you're on and what's immediately under the ground before you select the lift. And so if there, in some instances, if there is any doubt, you may have to have an engineer on the site tell you what an applicable load or concentrated load from the lift must, or what the maximum load that lift may generate on site. They may set that specification, so just to ensure that the lifts are safe to use on a particular site. Again, if there's any question, I think you need to start asking questions about what is actually under the ground where you are. Another question about support conditions is, do you need to drive while you're elevated? So is your plan of achieving this task related to actually moving the lift without changing your elevation? So obviously there are many lifts on the market today that allow you to drive while you are elevated to make it either allow you to continue a task in short intervals while you're elevated, or to move from task to task while you're elevated without having to bring the machine back down to the ground to increase productivity. And that really is something you need to know if the expectation is if you're going to drive while you're elevated while you're thinking about selecting an aerial lift, and certainly not after you've got one on site. So if I look at some surfaces, this is maybe a little bit extreme, but certainly a surface like this, you really have to understand that in a lot of cases your slab lift, aerial lift, scissor lift, or whatever type of lift it is, a lot of them are not really suitable for this kind of environment, and you will have to take some precautions to ensure that you don't have people driving into or around various holes on site. And unfortunately, when you don't do this, that is what can potentially happen, and obviously has happened, unfortunately, in the past. And so that's not an appropriate surface for that type of machine, and there are other precautions that you should take in that case to ensure that you have a firm level surface that doesn't have holes in it that you are using that particular machine on, or if it does have holes in it, you have to have some sort of control plan to ensure that you're not going to drive your aerial lift into those holes. This is a little difficult to see as well, but this was an instance where the slope around the building that they were planning on using this machine to access their work area was excessive, and unfortunately the machine went over backwards. It was also a loose gravel type material that really wasn't capable of properly supporting the wheels of this particular machine as it loaded the ground where it was. So again, that's not the proper type of application for that particular machine, or at least not as the site conditions were on that particular site at that particular time. And that may be true as well, that you may actually have to, in a construction site type example is that, you may actually have to do ground condition improvements or leveling or compacting of ground to ensure that on your construction site, if you're planning on using an aerial lift in that particular application, that you have suitable ground conditions. And so you may have to choose a particular lift that is suitable for that, or you may have to alter the ground conditions so that they're suitable for the lift, either or. But you do have to think about those type of things when you're choosing the lift. In this particular case, again, this one always baffles me, and I'll just spend a bit of an instant on it. But that is what we would technically or generally term as a slab-type scissor lift, and it is not designed or intended to be used in a rough terrain environment. And you can see in this particular case, obviously, I think they knew that they weren't going to have any luck with this particular lift at the time. They were attempting to make a makeshift type of ground condition on plywood that would be suitable. In general, plywood on these type of units, especially on a terrain that is uneven like that, is usually wholly unsuitable. And for the life of me, this one I still never really understand. They were traveling with the machine in a semi-elevated position there, and I'm not really sure where they were going, because it doesn't really appear that there was anything to access where the machine fell over, and I'm not sure why it was elevated at the time when it did fall over. So again, that's not a good practice. Another question that I had put on there was with respect to transport of the machine on site, and you can't forget that you may have chosen the right machine for a particular application if you take the application in isolation. So if you look at the fact that, for example, back when I had that photo up of the overhead crane and the scissor lift there, that's in a factory with a level concrete surface under it, and certainly an appropriate condition on which to use a scissor lift. The problem may be that you have to get the scissor lift into that condition in the first place, and you have to understand that in order to actually get it there, you may have to move it around a job site, and you have to take that into consideration, whether you expect that lift to be able to be mobile itself around the job site to get to it if it's an unimproved job site, or whether or not you're going to make additional allowances in order to get it to the place where it is suitable to operate. So if it is an unimproved job site and you expect that lift to go from place to place on the job site, you really need something that is more of a rough terrain type lift. And really, so answering the question about how you're going to get the lift to the task will point you to specific types and sizes of lifts. Types in that, as I just mentioned, if you have rough terrain to traverse, then you need to obviously have a machine that is capable of traversing rough terrain. And so from a scissor lift and a boom lift application, that generally leads to larger rough terrain lifts that have the abilities to be mobile in unimproved situations or ground conditions. When you talk about the size of lifts, then you start talking about how much room do you have to get the lift around. If you have to get it into a small service elevator, if you have to get it through a standard door to access the workplace, then obviously you're going to have to find a lift that has the maximum dimensions that allow you to get it into those particular areas, and or the weight restrictions, or you have to have a maximum weight if you're going to planning to put it on an elevator of some sort. So as I said here, small scissors and vertical lifts can go through standard doors and onto elevators generally, right? And certainly if that's part of your plan to use it as construction, then you have to account for those type of things and get something that's suitable and understand those specifications of the machine. And as I said, many units designed to traverse rough terrain on job sites, and those were the ones that you'll use to get to suitable elevating positions if you have to get around unimproved surfaces on a job site. So this is a rough terrain scissor lift, and as shown there, it will go through mud and various grades and various types of soil conditions to get in and around the job site to a place where it's suitable to elevate. Now, having said that, where it currently is there is not a suitable place to elevate, but you have to get to some place that is suitable to elevate in order to, where you want to do your task. And if immediately below your task looks like this and it's not suitable to elevate, you may need a machine that allows you to reach from a place that is suitable to elevate to where you need to work. That one's a little difficult to see as well, I apologize, but that is a scissor lift on an elevator that was not quite properly installed on it, or not quite properly tied down to the elevator, and eventually was crushed between the elevator and the structure. So in this particular case, really what happened here, they've got an unimproved site here that's in the initial stages of construction. Unfortunately, I didn't really understand that what the height difference between this curb here and this top rail was, and the machine did bounce a bit here and wedge itself in a little bit at one point, and you know, it was not a good plan to try and get this lift in between that curb and that beam. How do you get the lift to the task again? You know, this is looking to get a lift down into the bottom of what I believe is, well, a secondary level of a structure. And again, I think in this particular case they were attempting to work while they were on that plywood ramp, because that's the only understanding I can have that the machine was actually elevated at the time. Certainly, if you wanted to get the unit down into this area, either you have to construct something that is suitable to bear the weight and the pressure of that particular machine, and obviously all the manufacturers publish those type of specifications, and if you have any doubt you can check with them. And secondarily, I guess if you can't build a structure to get it down there appropriately, you may have to get a forklift or a crane or some other method of getting that particular unit down into that work site. So other factors that are potentially out there, electrical installation of the lift. Are you going to be working near power lines deliberately and understanding that? Do you need a lift that is electrically insulated in and of itself? Is there a confined area at elevation, right? Do you have to try and get into a very small area? Do you need a small basket or a small platform, or do you need a specialty machine to actually get into that area? Are you anticipating wind? Have you got an indoor or an outdoor use for this particular or task to achieve? And do you have the proper machine? Machines have various wind ratings. Generally, most machines that are usable outdoors in North America have a 28-mile-an-hour wind rating associated with them, but that can vary. And ultimately, I guess you know, another tip, kind of a little bit outside of selection, but anemometers nowadays that are accurate enough to make an understanding of whether or not you should be elevating in certain wind conditions are available for under $100 today, handheld anemometers. Are you operating indoors? Do you have to worry about emissions of the particular machine or not, right? Do you need an electric machine, or do you need a machine that has the ability to be a hybrid type machine, or can you have something that has a internal combustion engine and you're not worried about capturing emissions? Optional equipment, do you need things like pipe racks or generators or welders or glazing packages, material handlers? What do you need to achieve your task, and which are outside of the scope of the aerial lift that you plan on getting for the task, and which one are actually need to be part of the aerial lift that you have to get the task or complete the task? And you know, in the specialty lifts, again, they are available. They're more expensive, obviously, but if you end up in a place where you feel that the scissor lift or boom lift that you're anticipating using is not usable for one of those reasons that I spoke of earlier, you may have to look at getting a lift that is specifically designed for that particular task or application, or to get into a specific area. So if I go back to this task analysis, as I said, one common error that I generally see when people talk about selecting aerial lifts is that they generally believe that one type of lift is going to be appropriate for all the tasks to be performed on a site. And you know, if you're an electrician or a plumber or something like that, or a subcontractor that's doing a certain specific scope of work within a job site, really what I see is that when people get into trouble, unfortunately, it's because they've got an aerial lift that is probably suitable for about 90 or 95% of what they expect their employees or their workers to do on that job site. And the problem is that it's not suitable for that last 5%. And people begin to improvise when they don't have the right equipment. And from a safety perspective, that's when they tend to get in trouble. And so if you do this analysis properly and you take it to all opportunities for it to be, or understand all of the tasks that you're going to need that lift for on that job site, certainly you can give your employees a better degree of safety or confidence that they do have the right piece of equipment. And unfortunately, you may have to get different pieces of equipment for that last 5%. But it really comes down to requiring the proper, it's the proper tool for the job. And that's really what you need to ensure that people remain safe on job sites. Again, I kind of got a bit ahead of myself, but really don't just use that lift because it's on site. You really have to understand that somebody's taken a look at this analysis and done a risk assessment of the various tasks on site that need to be completed. And is this the right piece of equipment for all of those tasks, or do I need different pieces of equipment for different tasks on the site? A little bit beyond that, and this is where I talk about people not having the right equipment for the job that they want to perform, and they start to get a little inventive. And certainly when you get inventive in cases like this, unfortunately that gives, certainly that machine was never designed to have people and or materials cantilevered off the railing system like that. And so not only is the railings themselves may not support it, but certainly you get into some higher elevations, depending what you put on there, the machine may become unstable as well. And certainly I think a lot of people believe that the factor of safety on these machines is much greater than it really is. Certainly there is a factor of safety related to stability, and we all have to meet certain standards when we test with respect to stability, but doing things like this and cantilevering loads can make you become unstable very quickly. So, are you still unsure? Right? We've gone through all of those things, and you really don't know if you've got the right lift, or you're not sure if you know enough to make that determination about the right lift. Really, I think at that point, you need to talk to your renter or your dealer about the facts of your job site analysis and get their recommendation, right? Certainly people who rent this type of equipment are on various job sites at various times. They deal with the equipment frequently, and I'm sure if you go to them and ask them for a recommendation on what particular type of machine you need to perform specific tasks on a job site, they can generally help you with that. Through all of this, you'll notice that I've said may and should a lot, right? And really it comes down to, because there are no hard and fast guidelines where you can say for a specific task this specific lift should be used. You really have to look at the specifics along with each job site and what's occurring there and how it's going to occur to make that consideration about what type of lift you would like to have. And then beyond that, if you get into a situation where your renter or dealer or knowledgeable person in your area is still unsure and can't really help you with whether or not you can use this particular type of unit or what type of unit you should use for a specific application, you can certainly go to the manufacturer at that point, and in a lot of cases they'd be happy to help you out with your special requirements. They may not always be able to give you the answer you want to hear, but most of them will listen to the arguments and your specific requirements and let you know whether they have something that can help you with that particular task or not. So I'm going to get to the point and believe that you've chosen a lift, and I'm going to throw in a last-ditch effort here to say, okay, you've got the right lift, and that's great. It's going to be able to do all of the things on your site that you want it to do, but do you have properly trained operators now for that lift? Because I'll tell you, if you do not, the care that you take in selecting the lift may go out the window at that point. So I would stress that everybody gets some sort of appropriate training for their particular types of lifts. And at that, I would just say, can we open up for some questions, Katie?
Okay, great. Thank you, Brad. We do have a couple of questions. If there are two different types of machines that fit a particular job, how do you choose between the two? And is there a general rule of thumb for selection?
Okay. The first answer, I think, for me is it becomes financial, right? I mean, if you've made all of those determinations and you've narrowed it down to 2 particular lifts that will perform that task, in my mind, that gives you the freedom at that point to decide that you want to take the lift that is going to be more cost effective for you in that situation. If it's a wash at that point, then I guess, you know, eeny, meeny, miny, mo kind of works.
Okay. When we discuss, oh, sorry, go ahead.
So that's a very scientific principle.
Okay. Eeny, meeny, miny, mo. Support conditions. Where would you find an engineer to find out the area that you're working your lift on? Yeah, and that one becomes a little more difficult. It really depends on what you're working on and how you're working there. You know, if you're working in new construction and like, let's say someone's erecting a building, usually there is an engineer, a site engineer, who's responsible for the entire site, right? And I think at that point, you really have to approach someone there to let you know what the specifics of the ground condition are. You know, if you're doing work, you know, in downtown Boston or something, and you're not sure about what's under the sidewalk, you may have to contact the city or you know, an engineer with the municipality wherever you are to determine whether or not there is, you know, a sewer main underneath you or whatever type of service that may be there. It's almost like a call before you dig, but it's find the appropriate person who knows the ground conditions before you elevate. And you know, unfortunately, I can't say that there's, you know, I can't point you to one specific person that's always going to be available to that. You have to have a little bit of local knowledge and history and an understanding of who's responsible for the ground conditions there. Okay, great. On an aerial lift, I believe they're asking about location of anchor points, but pros and cons of anchor points on aerial lifts. Okay, that's a bit of outside of selection, I think, at this point. But, you know, I think ultimately the manufacturer has an anchor point on a lift, and ultimately that's the point that has been designed as applicable for your fall protection system for you to hook it up. You know, how long your lanyard is and those type of things are a bit out of the bounds of this, but certainly, you know, if you're on a boom lift, the requirement is that you wear some sort of fall protection, and ultimately that fall protection has to be attached to the manufacturer's anchor point. Okay. From a safety perspective, how safe is it to drive while the machine is elevated? I think as long as the ground conditions are suitable, and you know, and you've done that kind of risk analysis. I mean, there are a lot of factors in that question, but if the ground conditions are suitable and there aren't any obstructions, you know, elevated obstructions that you are potentially going to run into, and/or electrical lines or whatever, as long as the lift is rated to be operated while elevated, it is not a risky proposition. I mean, there are parameters set around the design of units that allow them to be driven in an elevated condition, and generally they end up with lower drive speeds and certain, obviously, parameters around them. But if the manufacturer has tested and rated that machine that it is available to be driven while elevated under the right conditions, it's not a risky proposition. It is designed to do that, and it is safe to do that. Okay, so it's not like a telehandler where you where it's recommended that you lower the forks as low as possible while you're operating the machine. Correct. It's not like a telehandler in that you know, some of the ability or some of the reasons for having an aerial lift is to increase your productivity and allow you to do these tasks and remain elevated while you're moving from task to task, and they are designed to do so. And so I would say, as long as the conditions are proper, it is safe to drive machines that are rated to be driven while you're elevated. Okay. 2 more questions. Is 1,000 pounds in a boom lift, is that a realistic maximum capacity? In some boom lifts, yes, and I think that, you know, it's obviously that depends from lift to lift. Obviously, capacities of any aerial lift is based on the manufacturer's
design and testing of that lift to meet the requirements and the standards that are applicable. But certainly there are boom lifts out there that have a capacity of 1,000 pounds as rated by the manufacturer, and if the manufacturer has rated them and they are compliant with the standards, which there are, again, I'm not trying to say people aren't compliant with standards, so there are boom lifts there that are 1,000-pound capacity that are realistically and safely 1,000-pound capacity machines.
Okay. Last question. You discussed transporting the machine on site. Oh, there's one more question too. You talked about transporting the machine on site, but what about transporting the machine to the site? Are there equipment selection considerations when getting a machine to the job?
There may be. I didn't really go back quite that far. I mean, there are obviously, in general, most aerial lifts arrive on a job site, on a tractor trailer, or not a tractor trailer, but a flatbed type of truck, depending obviously on the size of the unit. In general, I would say I don't think there really is. Most of them are trafficable in general highway situations, and so it's not that much of an issue. Certainly, I guess if you get into some of the very large lifts there, you may have special conditions to get them from job site to job site. And I guess if you own them, or if you are renting them for a long period of time and you're planning on doing that, then you will obviously have to understand that and make concessions for that. If you're just renting them from site to site, generally that's the responsibility of your renter to get it to your job site, right?
Okay. This is just more of a comment from an attendee, but the comment is that he believes that generals on the job site are not taking a lot of responsibility and are pressuring contractors to get the job. Many of contractors taking more risk to complete their tasks. Maybe the ground should be groomed for the contractor. We're talking about ground support.
Yeah, and for a subcontractor even, right? Mm-hmm. I would say that, certainly there's always pressure, there's pressure in every industry to do things more quickly and for less money. But I think ultimately people's safety has to take precedence over that. And, there may be contractors out there like that who, regardless of what you tell them, will not care about that. I know certainly I've spoken with various contractors and general contractors who have told me that they really wish that if the conditions are inappropriate for the electrician to go up beside the building because we haven't compacted our fill there yet. Honestly, I've had contractors who would tell me that they wish that the subcontractors would come to them and tell them that, because they don't want an aerial lift on the ground any more than I do or anybody else does. And so again, I think that I don't think you can generalize contractors. I think some are very safety conscious, and I would agree that some really just want to get the job done. And if you're a subcontractor on the site and you're responsible for people going up in an aerial lift, I think it's your duty at that point. It's your duty as an employer to ensure you do everything to give them a safe work site. And if that means going to the general contractor and having him prepare a safe work site for you, that's what you need to do.
Okay, great. Looks like those are all the questions that we have today. Thank you, Brad, and thank you everyone for tuning in. Next week is our last presentation for the Safety Conference webinar for this year. It's on December 15th. Same time, same place, Thursday afternoon at 2 p.m. Eastern Time. Rich Stollery with GAR Equipment will be talking about new site inspection strategies using the ICE 100 plan, an acronym for looking at ground conditions and inspecting your site with that plan. Sign up at safetyconference.com. If you have any questions, my name and phone number and email address are at the bottom, and we thank you all for attending again. See you next week. Thanks, Brad.